Click on this subscribe button to watch more videos on my YouTube channel. To get latest notifications and updates about my videos, click on this bell icon. Hi friends, in this video I'm explaining one of the another basic tutorial. There's nothing but there. Go on to the mechanical design and go to the part design workbench, and one of the dialog box will appear. Give the part name as you wish. I'm giving the what I developing on the before. I'm giving the one of the part name disintegrator block 3D. Already explained the 2D model, and some of the isometric views are also explained about this tutorial in the previous tutorials. You can observe on the previous tutorials and go to the XY plane. And go to the XY plane, draw the one of the circle. All the dimensions are mentioned in the drawing file. You can also download these drawing files in my description links. The files are available. I'm giving the dimensions of first I'm creating the one of the part, nothing but the pipe. The pipe of internal diameter is 300 mm mentioned in the drawing. All the dimensions are mentioned. You can observe, download this file, and I'm giving the 300 diameter, and the internal diameter is 300 and the outer diameter is 310 diameter, and the 5 mm thickness I mentioned. And click on the pad definition toolbar, and it appears, pad definition appears, and give the length of distance. Total height is 600 mm is required, and click on preview and click on OK. One of the pipe is created. I want to give the more option, give the two types, first limit and the second limit on the 300 and the 300, because the plane is required on the both sides. The flanges are same, then only I'm doing these operations. See the full tutorial. You can observe on the in the middle part. You can observe why I'm taking like this, and go into the XY plane and simply select the top of the plane and draw the circle of flange is required. The flange consists of razor face and the holes. PCD pitch core diameter is required, and the outer diameter, internal diameter. I am placing the 425 outer diameter first, and I am placing the diameter of on the screen and 310 diameter, and go on to the exit workbench and go on to the pad definition and giving the length of 20 mm thickness on mentioned on the drawing. When observe on the drawing, it is mentioned 20 mm thickness. Give the 20 and click on preview and click on OK. See this, the 20 mm, and go to the plane and draw the PCD diameter, pitch core diameter of the circle, nothing but the pitch core diameter. By selecting the profile toolbar, different types of tools are there. I am giving the circle profile and select the exit constraint definition. I am giving the constraint definition of dimensions. I am giving the dimension to edit 380 mm. PCD is required, and the small hole is required. For example, I require 12 number holes. I am giving the 18 die holes are mentioned in the drawing. I mentioned the drawing. I am preparing the all of the holes, and go on to the exit workbench. First create the pocket of that hole. Using the pocket definition, click on preview, give the 20 mm distance, and the one of the hole is created. By reference of this hole, you can create the all of the 12 holes, and go on to the instantaneous and the circular pattern definition and angular spacing. Give the angular spacing of give the object, and click on preview and click on OK. Then it will not form. Once again, you go on to the instances. I'm giving the tall instantaneous and current solid, and select the reference element. See, required the 12 holes. It is by angular spacing, it does not changes. It is showing the 8 degree and changing it to 30 degree. Then it shows the 12 holes. Count the holes: 6, 7, 8, 9, 10, 11, 12 holes are created. Click on review and click on OK. 12 holes are created. Like this, you can develop the flange, and the rigid face is required. Go on to the sketcher plane, and the rigid face of how much 360 RF is required, and 360 diameter. I'm giving 360, and 360 rigid face is required, and I'm giving the circle pattern, and go on to the constraint. I'm giving the 360 of dimensions as per requirement, and go to the exit workbench and go on to the pad. I'm giving the 1.5 thickness. Before going to the plane, the internal diameter also required for the 360 RF. You can prepare. I'm giving the 360 of diameter of 310. It is constant with the pipe OD, and go to the exit workbench and go to the pad definition toolbar and give the 1.5 thickness, and click on preview and click on OK. Then one of the razor faces. This is different types of flanges are explained, and the elbow pipes are explained in the previous tutorials. See the different types of flange with introduction of the flanges also explained with the theoretical matter and the practical explanations also I'm giving on the previous tutorials. The simple drawings I'm explaining about this. Go to the mirror why I'm taking like this on 300, and I'll explain on the before. And 300, select this plane. Simply you can do this process simply on other side also. You can create the flange without taking much time. See, the flange is created by the mirror tool on the transformation features right there. By selecting the plane, go into the plane. I want one of the plane of 310 by 2 on the plane is required. I want to develop this type of plane is required. Go into the plane definition, different types of offset from the plane you select. I'm giving the plane, and after giving the plane, go into the sketcher and draw the line of 190. Before develop the drawing, check all the dimensions, then only develop the drawing, and select the two lines and constraint and give the coincidence option. Simply coincident with the line with the horizontal line is coincident with the vertical line. It is somewhat distance is not coming. Simply again I'm selecting the endpoint and the line and coincidence definition and click on OK. It is fixed to the endpoint of the middle point of the vertical line of the horizontal line and the discriminator block. This is the drawing, all dimensions are mentioned. Last part I want to draw. First draw this by using the line command, by using the line operations on the profile toolbar. Give the line, I'm considering the dimension not mentioned in the how much thickness I not mentioned on the drawing. I'm giving the line of 10 mm and select the midpoint and give the constant and click on OK and click on this. The 10 mm is created. See, the somewhat time is taking. It is not possible. Then I'm deleting all these files. Again I want to draw like in different method. See, the constants also not there. I will show you the other method, and I'm deleting all the lines what I done before. See, I'm deleting all of the lines and I'm constructing constants like this and draw the line of I require the 10 mm thickness. For example, I'm giving the value of 10 mm on one side and draw the line of other side. Also I am giving the 10 mm. You can also use the mirror operations also on the about toolbar. Operations toolbars are operation tool, different types of operations are there, offset and the mirror, different types of. I'm giving the 10 mm on other side and draw the simply. You can also use this by rectangle operation also. I'm using the line operation and give the line of how much I require. 300 is required. Then I want to give the mirror command on the other side. The line I want to create, simply intersect the vertical line and points with the horizontal line by using the line operation and delete all of the operations before. Delete the above line to construct the 3D model of this part and go into the exit workbench and go into the pad definition. Give the pad definition of distance of, give the pad definition. Pad definition is how much is there. 300 minus 600 is 300. The 150 is required. I'm giving the 150 of length and click on preview and click on OK. You can also calculate the dimensions to develop this drawing. You should calculate the dimensions before you construct the drawing. The calculation part is very important to develop any of the drawings. And this is the one of the part is typing. Go on to the more, because it is constant with the circle part. I'm giving the 3 mm thickness because thickness of the pipe is 3 thickness. I'm giving the 3 mm. It is constant with, not on the above. It not touches on the solid material. See, it is simply constant with the all of the profile. The profile is looking good, nice. And go on to the plane. On the top of the plane what you object has created and go on to the lines by using the line operations. Give the line of 50 mm. See, this is 70 in the drawing. See, This 70 is the height, already explained. 150 minus how much the distance, you get the 50 mm dimension. Already explained the 2D practice drawing. See the previous tutorial and go into the constraints and click on OK and select the endpoint of the two with horizontal lines and the coordinates. Simply it is constrained with the endpoint of the line and go into the line. This is 150 dimension required. Go into the 150 value, give the value of 150. After giving the value and draw the line of again constant. How much is required? 50. 150 minus 50 is equal to 100 mm. And intersect this line, and it is 150, it is okay, and simply intersect this line. One of the profile is required for to remove the material from the solid material. Then only I am preparing like this and delete all the lines after creating the profile, and go into the exit workbench and click on the pocket definition and click on preview and click on OK. See, some of the material is not removed, of minor thickness of remaining. I will show you how to remove this. Simply delete this line, the profile is completed, and go into the sum of the line. Consider sum of the line of the horizontal and the vertical line. Simply go into the trim. Trim different types out there. Go into the trim operation and select like this. The line is extended and constant width like this, and go to the exit workbench and go to the pocket. See, the minor thickness is also not there. The material is totally removed and the profile is completed. You want to develop this by using this method also. This is the one of the basic tutorial for the beginners I'm explaining in the 3D in the part design workbench, and simply go to the mirror operation and what is previous. Simply you can develop this with two parts. You can develop by using the mirror operations on the transformation features. Transformation features are very important to develop the different operations in CATIA VFX software. This is the multi-view section. Different types of views are there. Top view, side view. This drawing is available in my description.